All right, today we're doing something a little different. We are going to take a fraction, for example, the fraction 3/4, and we are going to decompose this, but not as an addition sentence. We're going to decompose this as a multiplication sentence. So the first thing I want to do is start off by drawing my tape diagram, and I'm going to break it into 4 equal parts, and I'm going to shade in 3 of them to represent my fraction 3/4. Now, first thing, to break it up into unit fractions, I have 1/4 plus 1/4 plus 1/4. Now, when you look at this and when you think about the rules of multiplication, we know that multiplication is the number of equal groups. So how many equal groups do I have? I have 3 equal groups, and what is each group made up of? 1/4. I have 3 equal groups of 1/4. Together, as you can see in this picture, that 3 times 1/4 makes up 3/4. This next fraction is a little more challenging because, as you can see, this fraction is greater than 1 whole. With the fraction 10/8, I know that in 1 whole there would be 8 equal parts. So the first thing that I need to do to represent this on my tape diagram is to make sure that I know where my 1 whole is. These are my 8 equal parts, so that is 1 whole, and then I have 2 additional 8ths. So to write this as a sum of unit fractions, 1/8 plus 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 1/8. Let's see, I just want to double check. 1, 2, 3, 4, 5. I have a total of 10/8. Now, to write this as a multiplication sentence, I want to think about how many equal groups I have and what the value of each group is. So in this particular example, I have 10 equal groups, and each group is 1/8. So 10 equal groups of 1/8, or 10 times 1/8, equals 10/8. I can decompose this even further. Let's put some parentheses in here and write some new multiplication sentences. So in this first parentheses, I have 8 equal groups, and each group is worth 1/8. So I have 8 times 1/8. And then in my last set of parentheses, I have 2 equal groups, and each group is worth 1/8. So when I do the multiplication, 8 times 1/8 is 8/8, and 2 times 1/8 is 2/8. I could add those up to 10/8, but I also know that my 8/8 here, my 1 whole, I can rewrite that as 1 whole plus and 2/8, 1 whole and 2/8. Now I want you to think about how you can write or draw a tape diagram for the fraction 5/3. Think about what that would look like. Is it greater than 1 whole? Is it less than 1 whole? How many parts will you have? How many parts will be shaded? So if I were to draw a tape diagram to represent this fraction 5/3, I would first draw 1 bar, and I know I have 5 equal parts, so I want to divide this into 1, 2, 3, 4, 5 equal parts, and I know that within 1 whole there are only 3. So I'm going to put my brackets up there to indicate that that is 1 whole. I can write this as a sum of unit fractions, 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. Together those would all add up to 5/3. And there are different ways that I can break these up and write this as a multiplication sentence. I'm going to start putting my parentheses there. So for the first set of our parentheses, I have a total of 3 equal parts. Each part is worth 1/3, so I have 3 equal groups of 1/3, or 3 times 1/3. I'm going to add that to my second parentheses, in which I have 2 equal parts. of 1/3. So it's 2 times 1/3. 3 times 1/3 is 3/3, and I'm going to add that to 2 times 1/3, which is 2/3. And you can see exactly what that looks like here in the tape diagram. So to write this as a fraction, I can just add my numerators, 3 plus 2, that equals 5/3. But we also know that this fraction, 3/3, is 1 whole. So I can write this as a mixed number, 1 and 2/3. So what I've done is I've taken the fraction 5/3 and I've decomposed it from an improper fraction, where the numerator is larger than the denominator, to a mixed number where I have 1 whole and then I have the fractional part that is left over.